Okay, in this podcast, we're going to take a look at a totally different type of bonding. We've been doing ionic bonding so far. It was a 3-step process for us to get to full ionic bonding. And this one's covalent bonding.
So much simpler.
Yes.
Covalent bonding.
These are
One
compounds
step.
that actually form molecules. Remember we said in ionic bonding that they're not actually molecules? These actually
Kind
are.
of networks.
Yeah.
They result from sharing electrons. Those two words, they should almost be the same thing in your head. When you think covalent, sharing.
Yes. Sharing.
Covalent, sharing.
I always think of the covalent compounds as the friends of the periodic table, and the ionic compounds are the lovers of the periodic table because they're attracted to each other.
So friends share.
Yeah, and lovers are attracted.
Lovers are attracted to each other.
Right. So
I can't believe you said lovers in a podcast.
I know.
But there it is. So
I'm
ionic,
just trying to sound like my grandma.
because they give and take electrons.
Yes.
They exchange electrons.
And then they're attracted to each
and
other.
they're attracted to each other.
They think each other are good looking, and they stick together because of that.
And covalent shares
They
electrons.
sort of have shallow
I'm
relationship.
gonna move on from this analogy.
I think we've kind of beat it to death at this point.
Occurs between nonmetals.
Yes.
So two nonmetals, they're all on the right side of the periodic table.
If you see a metal in a compound, it's not covalent.
No, it is not. And it makes a molecule, which we said, specific type of compound. All atoms have an octet of electrons. Now think back to your Lewis diagrams. It makes a lot of sense. They're sharing to get a full octet. And we've kind of already been over some of that. Here's just a picture of water. The hydrogens, they only need 2 electrons because they're in the first row, where the oxygens need 8 in their outermost shell, and we have a full octet there. Naming them, this is the simple part, as that arrow is pointing to that diagram. This you need to know. Memorize it. Odds are you already have it memorized, most of it.
Most of it.
One,
Actually, all of it, I would say.
they're just Greek prefixes.
Mm-hmm.
1 is mono. 2, di. Not bi, but
Right,
di. So
di.
some of them you have to keep track of. 3 is tri.
Like a triangle.
Triangle.
Mathematics
Yeah.
coming into play here.
Greek
Yeah.
word.
Yeah.
4, tetra.
Tetra. Yeah. We don't really use that prefix too much for anything else, I don't think.
Oh, but we do, Mr. DiGiacomo.
Oh.
Think about it. Tetra. You know any games that you might play with that?
Oh, Tetris.
Tetris.
Yeah.
Everybody knows 4, tetra. Why is Tetris called Tetris?
All the shapes have 4 blocks to them.
All the shapes have 4 blocks in them. So let's think about it. You've got the vertical piece. Oh, this is awful. 4 blocks.
Here we go, 4 blocks.
You've got the T's, 4 blocks. The Z's, 4 blocks.
Mr. Manor, I think this might be a complete waste of time on this podcast.
Tetris.
Yeah.
Tetra means 4.
Sweet.
Yeah, I bet they learned the prefix tetra now.
Probably.
Tetra
Indeed.
means 4. Tetris. All right, back to everything else.
Okay,
5
so
is penta,
5 is
hexa, blah, 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 blah.
penta, hexa, hepta,
You need to
octa,
memorize
nona,
those.
Deca, dodeca.
Don't worry about 12.
I've never even seen that.
Why do
in
we need
chemistry,
those? Because those are going to tell us, ionic, we figured out the charges to tell us how many of each atom we had. Covalent, we use the Greek prefixes. You just tag that on the front of the molecule name. So the first element, full name, and a Greek prefix.
but there is an exception to that rule. If the first element, there's only one of them, you don't use mono.
Just like
So,
1x. You
yeah.
don't write 1x, you just write x. You don't need to use mono because it means 1. So if there's no prefix, assume it means 1. Second element,
So we use the IDE ending just like we did in the ionic compounds and a Greek prefix.
that's only on the second one. So
Right.
Greek prefix
IDE ending.
with the molecule name in the middle.
Yep, with the molecule root.
The root in the middle.
Yeah.
So for example, PCl5.
Okay, so some naming examples.
Let's see what we got. Phosphorus and chlorine. PCl5.
There looks like there's 1 phosphorus there and 5 chlorines.
Okay, so we need our Greek prefixes. How many phosphoruses are there?
1
Mono.
mono,
Chlorine.
5
Penta.
monophosphorus. Wait.
Oh,
It just says
you forgot the
phosphorus.
exception. Monophosphorus pentachloride, except
Right.
you don't write mono only on the first element.
Yes. So we still have the penta there for the chloride. Showing us
Pentachloride.
5, right?
And the IDE ending,
But
like
no mono.
we've always done. No mono on the phosphorus. If it was flipped, we would say like there were 5 phosphorus and 1 chlorine, we would say monochloride. You do put the mono on the second one,
Yeah.
but not the first one.
Yeah.
Okay, kind of tricky. It's like carbon monoxide. Think about it. Write the formula.
So
P4O6.
again, we see phosphorus popping up here. It's a popular element in this podcast, apparently. 4 phosphorus. 4.
I just know that. It's tetra.
Yeah. I wonder how you knew that one.
And 6 oxygens.
Hexa.
Like a hexagon.
Hexagon.
Think about your geometry there. Tetra phosphorus, full name, hex oxide.
Notice it's not hexaoxide. Again, it's going back to that whole old English thing.
Good English.
We don't put 2 vowels in a row usually.
At least not with these.
Yeah.
There's E's and U's. And another example, N2O3. You're just tagging prefixes on the beginning of these. It's really that simple. 2 nitrogens. 2 is di.
Di, yeah.
3 oxygens. Tri. And IDE ending.
Dinitrogen trioxide.
Trioxide. There's 2.
Nice.
Now there's 2 vowels. Try and
There
explain
is.
that.
I can't explain that.
I can't either. Just go with
That's
it.
why I'm not an English teacher.
Just go with it. Trioxide. Writing a formula from the name. Again, not too hard if you have the prefixes memorized, but you need to know what the prefixes are. You use the prefixes in the name to determine the subscripts. So backwards. For example, I think we needed that bullet to say that this was an example. Sulfur dioxide. Sulfur.
Sulfur's S, right?
Yep.
How many of them, though?
I don't know. It doesn't tell me.
Well, that must mean 1 then.
Oh, because
we dropped
there's a
monos.
mono. We dropped the
Yeah.
mono. So there's 1 sulfur and 2 oxygens. SO2.
Sweet.
Dioxygens.
Yeah.
2 oxygens.
Oh, this is so easy.
Dioxygen. Difluoride. Di, I think we just told you, means 2. So
Yep.
literally just read it. Dioxygen. 2 oxygens and 2 fluorides.
O2F2. There it is.
Trinitrogen. Hexachloride.
Tri meaning 3.
3 nitrogens.
Yep. 3 nitrogens.
6 chlorides. Hexa means 6. 3 nitrogens
N3CL6. There we go.
and 3 Cl6. Okay?
And then,
Prefixes are important.
okay, so
Practice.
some practice. We've got 2 practice. 1 with a name where we're going to write a formula, and 1 formula where we're going to write a name. So we'll start off with the name and try to write a formula from it. Oxygen difluoride.
There's that exception again. We've got the mono rule
No
where
prefix.
there's no prefix here. So we take that absence to mean
1.
1.
1 oxygen.
Difluoride. Di means 2. So O,
O2. Oh, wait, sorry.
O1.
O1
Difluorine, F2.
of 2.
CO. That's the one we told you about, but now I want you to see it.
So there's 1 of each,
There's
right?
1 of each.
So it's like
mono and
monocarbon.
mono. Mono, al mono. Monocarbon, monooxygen. Except
We don't write mono for the first one. So it's just carbon.
carbon, we do write it for the second one. Monoxide.
Yep.
Monooxide. Carbon monoxide. Now you know the formula for that.
That's pretty much
Where
it.
it
That's all
comes
there is to
from.
covalent bonding.
Yeah. If you're still here, you can stop now. That's the end of the podcast. Enjoy the rest of your day.
All right, it's over. You're done.
Go home. Unless you are home. Then go to bed. Or eat dinner.